Goodbye Deep Space Gateway, hello LOP. Now, just in case you're wondering what I'm going on about, this is the news that the next space station, the one to replace the ISS, has had a bit of a Trumpian makeover and will now be called the Lunar Orbital Platform Gateway, or LOP, instead of Deep Space Gateway, but we'll come back to that a bit later. Now, the most expensive object ever built was the International Space Station, which, combining launch, assembly, maintenance and contributions from Russia, Europe, Japan and Canada, has so far cost more than $150 billion. Using that price tag, if we assume that the ISS has had some 20,000 person days from 2000 to 2015, that works out at about $7.5 million per person per day. The previous US space station, Skylab, was about $5.5 million per person per day. Even by the standards of space programs, $150 billion is an astronomical sum. The entire cost of the Apollo program, adjusted for inflation, has been estimated at $109 billion, and the Constellation Mars program, which was in 2000, was projected at a mere $40 billion. The bill for the ISS will also continue to rise. NASA has recently committed to a future investment of $3 billion per year until at least 2024. But why has a space station received so much of NASA's budget when many other ambitious programs suffer cuts and cancellation? To answer this question, we have to look back at the history of the first space stations in low Earth orbit. In the 1960s, both the USA and the USSR invested in designing massive rockets specialised for lifting super heavy payloads into orbit and onto the moon. The Saturn V could carry an unsurpassed 140 tons into low Earth orbit. The Soviet N-1 rocket was designed to lift 95 tons above the Earth, even though it never actually made it past its first 4 test flights. Though its successor, the Energia, which flew the Buran into orbit, was able to lift 100 tons. When it became clear that the Americans would be the first humans to land on the lunar surface, the USSR shifted their focus to another thing you can do with a super heavy launch capacity. This shift in focus began an ambitious program of space station development, the Soviets launching 4 Salyut space stations and 3 Almaz military stations between 1971 and 1986. America answered with the 1973 launch of Skylab, a 77-ton station built from a modified upper stage for Saturn 1B, which hosted 3 manned crews before re-entering over Australia in 1979. And from that point, the US then concentrated on the space shuttle. Although the Soviet Salyut stations were much smaller, at less than 19 tons each, they paved the way for Mir, the first modular space station. But when the USSR collapsed in 1991, Western governments worried that the brain drain from Soviet rocket labs could provide rogue states with engineers and scientists to spread ballistic missile technology. To avoid this, the American government searched for ways to keep Russian engineers employed in peaceful space projects. One solution was to repurpose the plan for the Soviet Mir-2 space station to form part of a new International Space Station. This was agreed upon, and the first modules from the Mir-2 were adapted to form 2 of the core modules of the ISS. The ISS also provided continued employment for American engineers and the Space Shuttle, which flew 26 missions to lift the components into orbit. Visible from all over Earth as a bright dot racing across the night sky, the ISS provided an impressive and expensive collaborative purpose for the world's space programs, at a crucial moment at the end of the most violent century of human history. But after decades of development and investment, the ISS will at some point in the not too distant future be abandoned to the forces of Earth's atmosphere, ending its 30 years or so mission as the most expensive firework display in history somewhere over the Pacific Ocean. Meanwhile, the space industry is going through another period of turbulence, a new space race, this time between public and private agencies. Looking ahead to the next decade, NASA has gone back to the drawing board to plan a new international space station for the 2020s. This project also appears to have the support of the current US presidential administration. If you were thinking that by now we would have space stations with giant centrifugal rings creating artificial gravity for the living and working quarters, like the ones that were all the rage in the sci-fi films 50 or so years ago, then you'll be rather disappointed. In fact, if you're comparing the LOP-G to the ISS, you're going to be disappointed. The LOP-G in its current form will be a lot smaller, with just 4 modules compared to the 16 of the ISS. Like the ISS, the LOP-G will be a collaborative venture between private and public entities, and will draw upon funding from NASA, Roscosmos, ESA, JAXA, Japanese Space Agency, and CSA, the Canadian Space Agency. Unlike the ISS, the LOP-G will draw upon designs of previous cancelled projects. The first proposed module is the PPE, or Power and Propulsion Element, and will provide, as the name suggests, electrical power plant and an ion thruster propulsion capability. The PPE will feature international docking system standard ports at either end for connecting additional modules, and ones like the next generation Russian spacecraft, and possibly, at some point in the future, a Chinese module. The PPE is based on a robotic spacecraft designed as part of the Asteroid Redirect Mission, or ARM. That mission, which was defunded last year, and aimed to land on a near-Earth asteroid, capturing a boulder and returning it to cislunar space for study by astronauts. The 7.5-ton PPE module is set to launch on the Exploration Mission 2, EM2. That will be the second mission for the SLS and the Orion spacecraft in 2022-23. This will also be the first manned flight of the Orion crewed module, so mission success will depend a lot upon the new systems functioning as planned. SLS will deliver the Orion and the PPE to a translunar injection orbit, which will then set the space station off towards a course to the Moon. Then the PPE's thrusters will fire for the first time to complete the planned orbit. This isn't a lunar orbit, it will be in cislunar space, which means an orbit between geostationary Earth orbit and lunar orbit. Here the space station will remain outside of much of the Earth's and the Moon's gravity wells, allowing efficient access for future missions either to the Moon or back to the Earth. The SLS Block 1B rocket can actually lift 39 metric tons into translanar injection orbit, enough to lift all 4 sections of the proposed LOP-G in one launch, or 2 depending upon volume limitations. However, the current plan is to launch each module alongside a 23-ton Orion spacecraft and deliver the habitation module, then the logistics module, and finally the airlock by the middle of the 2020s. On each of these missions, a 4-person crew will be able to remain at the LOP-G for up to 21 days, doubling Orion's maximum mission time. So if the LOP-G is going to be much smaller than the ISS, what will it be used for? One of the main goals is testing equipment for the upcoming Mars missions. When the LOP-G is fully assembled with its 4 modules, the airlock will double as a berth for the construction of the new deep space transport. This large interplanetary spacecraft will be a reusable manned craft to take humans on towards Mars. The LOP-G will also be outside of the Earth's magnetic field and the protection it gives against charged particles and cosmic rays. Now, some might say, why do we need to redo all the testing when it was done with Apollo? Well, the longest Apollo mission was Apollo 17, and that was 12 days long, including 3 days on the Moon. And compared to now, it used 60-year-old tech. We've learned a lot since then, and manufacturing techniques have changed dramatically, but it still needs testing. Missions to Mars will be 6 months there and the same coming back, much longer and in deep space where no human has been before. The LOP-G gives us the best opportunity to test for conditions like this, but still be relatively close to the Earth. It could also be used to remotely operate equipment on the Moon and be a stopping off point for the next generation of lunar explorers as they transit from the Earth to the Moon and then back again. However, if the LOP-G can demonstrate and prove the technology needed to survive beyond the Earth's magnetosphere, then a proven launch platform such as the SLS, or maybe a private company like SpaceX, it may open the door for a more long-term program of more ambitious missions around the solar system. As always, a giant leap forward in political cooperation will be necessary before we take the next steps towards manned exploration of our planetary neighbourhood. So do you think we'll get the LOP-G up and running by the mid-2020s, or will it fall victim to the political flip-flopping that has plagued previous space programs? And will the SLS, at $1 billion a launch, be sidelined at some point in the future for a much cheaper reusable system? Let me know what you think in the comments. Now, I'd also like to take time to thank all of our Patreons for their ongoing support, and you can find out more about that in the link now showing. And don't forget the Curious Droid Facebook group and page for suggestions and ideas for upcoming videos. So, until the next time, please subscribe, thumbs up, and share.